Hey everybody, it's Ripley again. Hope you all are having a good day. Let's put a bow on this chapter, shall we? Let's get it done. This is the last little section. What we're going to talk about is we're going to talk about functions. We're going to talk about functions derivatives and functions second derivatives. But really, and this is super important, I want you to understand that all three of these things are functions. All right? Remember, function is differentiable at a point if it produces a value and one value only, which means its first derivative is going to be a set of single points that come out, right? Which produces a function. Likewise, when I take the second derivative, right, which is the first derivative of f primed, okay? So let's talk a little bit about what f prime says. F primed with respect to f. Now, real simple, and you're probably already there. This is probably silly. Think about this. If this is f of x, right, what do we know about f prime? Well, f primed is going to be the slope of all of these tangent lines. All right, so this tangent line and this tangent line and this tangent line and this tangent line. It's just going to spit out these slopes. So this is going to be x1 and this is going to be x2 and x3, etc., x4. So if I take f primed of x1, this gives me the slope of the tangent at x1. Now you already know this. I know that this is redundant, but really what does that mean? Well, in this case, what's f of x doing? Well, I don't know. Look at the slopes of the tangent lines. The slope of this tangent line is greater than 0. It's greater than 0. It's greater than 0. It's greater than 0. So what does that imply when f primed of x is greater than 0? Well, what's the function doing? This implies that f of x is increasing. All right. Now, this is really simple. It's super simple to look at, but please don't get cocky. This can get really complicated really quickly. Well, likewise, if I've got a function over here, if I've got a function that's doing this, right? Well, what are the slopes of the tangent lines? They're all going to be negative, and this function is clearly decreasing, which implies if f primed of x is less than 0, what must the function be doing? Well, it has to be decreasing. These are the last time I'm going to write these out, by the way. Now, the book doesn't really talk about this, so if you're reading the book kind of along with these lectures, then you may or may not see this. So what about if f primed of x equals 0? Well, remember, f primed of x is the slope of the tangent line. So if f primed of x equals 0, let's talk about the ways in which that can happen. All right, if I have a function that does this, ooh, that's a badly drawn function. Do you agree that, wow, sorry guys, the pen's a little loosey-goosey today. Oh, that's just terrible. Well, pardon me guys, I apologize. It can do that, right? Do you agree that the slope of the tangent line here is 0, which implies that f primed of whatever that point is 0 at that value? True? Well, a function can also do this, right? The slope at this point right here, that's a little bit better, right? Swing and a miss. So sorry. So the slope of that line is 0, which is equal to f primed at that value. I should probably call that x, and I should probably call that x as well. Right? Now you got to be careful, because there's another type of function here where the slope of the tangent line can be 0, and it looks like that. Now, that's kind of swoopy. I probably shouldn't have drawn that quite as swoopy, like that. All right, now, this right here, notice the slope of the tangent line equals 0, which implies, again, f primed of x, if this value right here is x, is equal to 0. Now, notice, sometimes students will say, okay, if the first derivative equals 0, then that implies, clearly in this case, this is called a minimum, right? It's at least a relative min, and we'll more clearly define those down the road. In this case, I have a max. But what the heck is this guy? Well, there are two terms for this. I should probably bring this over here. It's neither a min nor a max because, I mean, look, it's not bigger than all of the values around it because these are bigger. It's not less than all the values around it. It's less than these guys. It's not less than these guys. This is called a saddle point. Okay? And it's also called a point of inflection. And we'll define that here in just a second. All right? And I'll define why it's called a point of inflection. All right? So really all that we can say when f prime of x equals 0 is that f of x levels off. Wow, my pen has a mind of its own today, I'll tell you what. I take no responsibility for this thing today. All right, levels off. That's it. That's all we got. That's what the first derivative tells us. Okay? Now, let's stumble over this way. Let's talk about the second derivative. How about f double primed of x? What's this tell me? Now, the most important thing, and I've said this over and over and over and over again, but I want to make sure that we get this. F double primed of x gives same info about f primed of x as f primed of x gives about f of x. Okay, so think about this. If f double primed of x is greater than 0, well, what does this imply? We know for sure, since if I stumble back over here, remember when f primed of x was greater than 0, f of x is increasing. And since f double primed of x is f primed of x's first derivative, remember, if I take the derivative of f primed of x, I get f double primed of x. Now I'm mixing up my notation here a little bit, but don't panic about that. Remember, they're quasi-interchangeable. All right, then doesn't that imply that f primed of x is increasing? Now, let's discuss what that really means. All right, if f primed of x is increasing, and I'm going to discuss this vis-a-vis the initial function. All right, increase, perfect. Okay, now let's think about this. There's two ways that f primed of x can increase. All right, now just try to visualize these functions. Remember, f primed of x is the tangent lines. Okay, so let's think about this. I'm going to draw kind of little stick figures over here. I can have tangent lines that do this, right? Now look at these. These are all tangents. All of these are tangent lines, right, to the function. So what I'm going to do is I'm going to fill in my function around these tangent lines like that, okay? Now, do you agree? Let's make sure that you agree with what I'm doing here. Do you agree that f primed of x, which is our first derivative, these slopes of these tangent lines are getting bigger. They're getting steeper. All right? Now, hopefully your spidey sense is tingling a little bit here. What do you notice about the function? It's got this nice bowl shape, and the bowl shape is directed upwards. Now you may say, well, Ripley, that's kind of more cattywampus to the up and to the left. Just up, all right? In other words, this thing, like a satellite dish, is pointed up, even though it may not be pointed straight up. Now, there's another way that you have to talk about, though. Now, think about this. What if f prime, in this case, let's look at this real quick. Let's look at this. In this case, f primed of x is greater than 0, and f double primed of x is also greater than 0. Now let's discuss why. Remember, all of these slopes are positive, which implies first derivative is greater than 0. Function's increasing. F double prime is greater than 0 because the slopes of the tangent lines are getting bigger as well. F prime is increasing. I don't know why I just wrote increase. Now, what about this guy? Watch. Now let's do the same stick figure. All right, now look. Notice, for sure, we know one thing for sure. Do this in blue. When I do my function, get out of there. When I do my function, when I fill my function in, it's definitely decreasing, correct? All right, there's no doubt about it. So let's write that up. F primed of x, in this case, is definitely less than 0, because my function is decreasing. Remember my function, this is f of x right here. My blue is f of x. However, look at these slopes of these lines. The slopes of the lines are increasing. This is more negative than this guy. This guy's still negative, right? All of these are negative, but this guy's more negative, right? It's steeper in the negative direction, more negative or less negative, less negative. This guy is more negative than this guy, who's more negative than this guy, who kind of looks horizontal, which implies that f double primed of x is greater than 0. The slopes are increasing. They're going from more negative to less negative. And again, we have this bowl shape upwards, like a satellite dish. It's pointed up. So the bottom line, the punchline of this sorted tale is that if f primed of x, f double primed of x is greater than 0, not only do we know that f primed of x is increasing, but we also know that f of x is concave up. Concave up. Okay? Now, excuse me, we'll play with some terminology that can get a little bit confusing with these down the road, okay? But for now, just know that if f double primed is if f double primed is greater than 0, then f is concave up and f primed of x is increasing. What about if f double primed of x is less than 0? All right, well, what does that imply for sure? It implies that f primed of x is decreasing. I'm going to start getting lazy here. F primed of x is decreasing. Okay, so let's think about that. What does that entail? So I'm going to assume that all of my slopes, all of my f primes, right, which are slopes of tangent lines to the function, are going to we'll start them positive. All right, so I'm increasing, but I'm increasing at a decreasing rate. So look, when I fill this guy in, what's going on here? Well, my tangent lines are decreasing, right? Because the slopes of my tangent lines are I'm sorry, my first derivative is decreasing because the slopes of my tangent lines are are decreasing, excuse me. Now, in this case, f primed of x is still positive, the function is still increasing, but it's doing so at a decreasing rate. Over here it was increasing, but it was increasing at an increasing rate, right? I know that makes your brain crazy, all right? But we also know in this case that f double primed of x is less than 0, okay? Now, check it out. Look at that. Which way is the bowl pointed? See how that works? Your spidey sense is probably tingling that if f double primed of x is less than 0, this implies that f of x is concave, concave down. By the way, I'll start abbreviating this as CCD, and this is CCU. Now, let's make sure that that happens when the function itself, let's be real careful here. Let's make sure that that happens when the function is decreasing as well. Okay, so let's think about this. How am I going to make something where f primed of x is less than 0, however, it's decreasing. So in other words, f double primed is less than 0. Well, it's pretty easy to see. Look. Okay, notice there's this guy's f primed of x. These are going to be tangent lines, right? Little stick figures. Isn't that this is steeper negative than this? So this is more negative. This is more negative. This is more negative. So my function is decreasing because f primed of x is less than 0, and f primed of x is also decreasing. It's becoming more negative. So in this case, f primed of x is less than 0 because we're decreasing. The slopes of all these tangent lines are negative, and f double primed of x is also less than 0. Now look at what's happening here, ladies and gentlemen. In both cases, f double primed is less than 0, and in both cases, I have this downward concavity. All right? In both of these cases, f double primed is greater than 0, and in both of these cases, we have concave up. So that's it, man.